indices in range.
Yeah, we will. Yeah. But I'll show you how to deal with those. We sort of have only dealt with them. We've only scratched the surface, but same principles apply. Just whatever you want to do, if you want to undo something, you do the opposite operation, you do it to both sides.
How do you get a square?
So how do you get rid of a square, right? How do you get rid of a square?
Square root.
How do you get rid of a square root?
Square.
So you square both sides. So it's just about applying that stuff. So it's actually not much more. These are much harder than dealing with indices. Cool? So 2 to the power of 6 divided by 2 to the power of 7, what is that?
1.
So remember with their division, what do we do with the powers weak? Take it away, so that should be 2 to the power of 6 minus 7, correct? Which equals 2 to the power of negative 1. X to the power of 3 divided by x to the power of 6 is x to the power of 3 minus 6, which equals
Negative 3.
x to the negative 3. Very good. Who got those without any help?
Me.
Very good. So, I know this is pretty hard to see, but we can write that as a fraction, can't we? So, 2 to the power of 6 divided by 2 to the power of 7, how does that look over a fraction line? 2 6 over 2 7, correct? Now, I can represent that as 1 over 2. Why can I do that? Well, let's have a look. Let's have a look at why I can do that. If I can write, am I within my rights to write 2 times 2 times 2 times 2 times 2 times 2 divided by 2 times 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 2. Yeah.
Yeah.
Is that right?
Yeah.
And right now we're thinking, thank the Lord for indices, because I don't want to do that ever again, correct? Am I within my right to do this?
Yes.
And this?
Yes.
And this?
Yes.
And this? And this? And this? What am I left with?
1.
So I'm left with 1 on the top divided by 2, correct? So I can represent 2 over 6, 2 to the power of 6 divided by 2 to the power of 7 as 1 on 2. Sweet?
Yeah.
X to the power of 3 divided by x to the power of 6. Well, that would look like this, wouldn't it? Kid, what would that look like? Actually, I picked on you enough. George, what would that look like? 1 over x to the power of? Have a guess.
3.
Geez, George, you're always deep and all of a sudden. Deep. Alright. So, we can see that A is the same throughout there. They're all different representations of the same thing, aren't they? So am I within my rights to say that 2 to the power of negative 1 is exactly the same? I actually don't even need that. I don't need the middle one. How can I write that? That is the same as same. 2 to the power of negative 1 is exactly the same as same. 1 over 2, correct? If x to the power of negative 3 is exactly the same as same. 1 over x to the power of
3.
3.
What do you
mean, why is it x to the power of 3?
Yeah, like why can't you just put 3 then instead of x to the power?
Well, let's have a look, right? So let's say we've got, that came from x to the power of 3 divided by x to the power of 6. So if that was x times x times x, just hold on, Martin, or I'll soon work the answer in that.
Lincoln.
X times x times x times x times x times x. What can we do at the top and the bottom, the first 3 terms?
Awesome.
We can cancel, and we are left with 1 over x times x times x. Yeah, thanks, thanks. Which is exactly the same as saying 1 over x to the power of 3. Sweet. So, that's a long way of getting to the law, because that's, and some people probably would have rather me just get straight to the law, but I'd rather show you how we develop these things. So if you get an exam or whatever and you forget how it works, you'll always figure it out. Because what law do we really need here? What's the law that we need to remember? What's the law we've used here?
Oh. Subtraction.
Yeah, subtraction, we're dividing indexes, correct? That's the division law. So for our negative indices, I'm going to write a to the power of negative m equals What's my law? I want you to write down what you think the law is. I'm going to give you 20 seconds to do that. So write down what you think the law is. And if you're stuck and you can't figure out, let's look at our examples. What was A here?
X.
What was our M?
-3.
What happened? What happened to our A? It did change. What happened to our value of 3? Where did it go? What happened? I'll give you one hint.
Will always be 1 on top.
Five seconds. And what is your law thinks, Paige? What do you think the law is? It does have a 1 on top. I can confirm that is the case. Brendan, do you want to help take over? Does your law have a 1 on top?
Yeah.
Yep. Just keep going. What do you think it is? A to the power of n? Does that work? Let's check. What was our A in the first one? Where did that 2 go? Bottom. That's good. The M was? Well, -1. Where does our M go? Why have we not got an M value here? We don't need one. Why do we not need one? This is the power of 1, isn't it? So the law still holds up. Cool? That is there. That is our negative index law.
So if you convert to a fraction, it won't be a negative indices.
Yep. Now for those of us who think, whoa, this is a Friday Period 5, why are we doing this stuff? I want something simpler. You're copying down what's in the box, obviously, and then in the blue, to deal with negative powers, we simply swap, or flip. I'm going to change it if you want to really simplify things. Flip the term and make the power, get rid of the power, positive. Do you reckon we like dealing with negative powers?
No.
So that's something to probably keep up our sleeve and keep in mind. Now we're going to do some practice questions, because obviously now that we've got this new skill we need to practice it. So we'll start relatively simple. Give me a letter.
W.
Z.
W to the power of negative. We won't go that crazy. We won't go power of -2. Okay, you can represent that as a positive indice. I'll go 2 times m to the power of -4. I will go 2x to the power of -2. And lastly, I will go 4x squared over y times x to the power of -3, and I'll make that y